We're going to talk here about the halide exchange reaction. That is, we're going to make alkyl iodides from other alkyl halides. The halide exchange reaction starts with an alkyl halide, usually an alkyl bromide or an alkyl chloride, and we react it with sodium iodide in acetone, right? So remember, acetone is a polar aprotic solvent that promotes substitution by the SN2 mechanism, right? So one thing we know about this is we're going to go SN2, right? The other interesting thing is that sodium iodide, because of the lower charge density of iodine, sodium iodide is soluble in acetone, while sodium bromide and sodium chloride are not, and so we get a solid precipitate, which makes this reaction metathetical, right? That is, we drive it forward by removing a product from the reaction mixture, which breaks up any equilibrium and increases the yield, right? So this is driven by that precipitation of sodium bromide or sodium chloride, creating a metathetical reaction, okay? Now, the reaction is a characteristic SN2 reaction. That is, the iodide ion approaches from the backside. The bromide ion leaves as the leaving group. The sodium bromide creates a solid, right? And we get our alkyl iodide, right? Now, there is an issue. Even though this is an SN2 reaction, in halide exchange, we often get racemization if we start with a chiral alkyl halide from the beginning, right? So this is S2-chlorobutane, right? And so our iodide ion attacks as a nucleophile. And we would expect, right, since it is an SN2 reaction, a classic inversion of configuration to the R2-iodobutane. The problem is, right, we still have iodide ion. And remember, right, the iodide ion is a good leaving group and a good nucleophile, right? It is a good leaving group because it is a very weak base. It is a good nucleophile because it is weakly solvated because of its low charge density. And so the result is other iodide ions in solution can come back and attack the R2-iodobutane, turning it into S2-iodobutane. But the S2-iodobutane can be attacked and be converted back into R2-iodobutane. And so that process keeps going in solution until you randomize the stereochemistry of your alkyl iodide. So halide exchange is a good method for converting alkyl halides, alkyl chlorides or alkyl bromides, into alkyl iodides. But because the iodide ion is both a good leaving group and a good nucleophile, you cannot, the reaction even though an SN2 reaction is normally stereospecific, because of this effect, the one problem with halide exchange is you do lose the stereochemistry if you start with a chiral alkyl halide.